Okay, hello guys. Uh, daily, daily liquid today is the question checking number is the sum of power 3. Uh, okay, let's solve the question. First, I will take some notes to you. Um, so that's given an integer and every we need to return true if possible to represent and sum of distant power 3 otherwise return false. So I is power 3 if the exit an integer x that I equal to 3 power x. So what does the question mean? The question means that we need to define the given the n number, and we need to check that if is the sum of uh, distant power of 3 that will be 2. For example, here it's n is 12, so we can say that it uh, 3 power 1 plus 3 power 2 will be n. And also uh, 91 is also 3 power 0 and 3 power uh, 2 plus 3 power 4 will be 91. So the 21 will not uh, can create by the distant power 3, so that we can that we return false. So that's basically the question. So how do we solve that question? So we also need to uh, see the constraint of that is um, 10 power 7. So that's constraint. We need to uh, do the time complexity will be O n O log n to pass the test case. So yeah. So how do we think that? How when so the first thought that we need how is that we can do the brute force solution. So uh, let me think that. So we do some brute force solution. For example, we have n is equal to n will be equal to something of 3 I plus 3 I 1 plus 3 uh, I 2 and plus to the ik. So we can say that um, the maximum we can say that the maximum of ik of 3 ik will be less than and will be greater than so the maximum ik will be the log 3 n. And so maybe we can say that it's equal or equal here. So that's why we can say that the ik the maximum power 3 will be less than or equal to log 3 n, and we write the recursive first param is about the I, and second param is the n itself. So, and we move that, and in each of recursion we have two choice. The first one, we need to include that power of I here. We need to include that by n minus, we plus that with 1 and I minus 3i, and in here we just move forward, we do not choose that, and here so on and so forth until we see that n is equal to 0, that we return 2. Yeah, so because we analyze that the ik will be less than or equal to the maximum, so the maximum the height here will be log 3, and the maximum choice that we have here is 2, so the time complexity of the recursion here will be 2 power log 3 n, and we can write that is n log 3 2, and we also assume that is n, so the time complexity will be n, and that will pass the test case. So, and also we also have that we need to consider that, for example, the method and the method 2 here, that we have the, so we return true if the 3 built from the 3 0, so that's why the n minus 1 module 3 will be 0, and if 3 not built from power of 0, 3 power of 0, we will be say that will be returned true if happen that case, because something that if we have the 3 power 0 here, it will be 1, and other will be divisible by 3. For example, by 1 is 3, it will be divisible by 3 also, and 9 will be divisible by 3, so it's just one that make the n that not divisible by 3. So how we can formulate that? So we can say that n will return false when the n multiplied by 3 will be true. How? Because when I minus 1, based on the case that here we say that if we not is 3, that not equal to 0, and that's why we return false. Also that n multiplied by 3 will be not equal to 0, So we can take some example here. If the 5 is multiplied by 3 will be equal to 2, and n minus 1 is equal to 4, and multiplied by 3 is not equal to 0. Also, and 5 minus 2 is 3, and divisible by and divide by n is 5, and n minus 3 is also not equal to 0. Yeah, I think that is. Okay, we need to code that here. For example, we write the recursive f here with I and n the power, and in here we check that if n equal to 0 we just return true. We need also to check that if the 3 power greater than or, and we just return false, and we return that f power plus 1 and minus power minus 3 power we need that we just and all. That's why we need just one case true, that the possible will and the all recursive will be true. So the f here we not choose that power and move forward, and we call the f here is 0 first, and then let's run this. Yeah, that's passed. So we also have the method 3 that we loop until the n we will give to 0, and we check that if n the modulo by 3 will be equal to 2, we just return false, and we take that and we divide n by 3 and we move forward. As here we, if not in case of 2, we will return true. So let's see that. So alright, so I think that will be log n time, because we just in each of loop we just divided by 3. For example, n minus n divided by 3, the first loop n divided by 3, and the second loop is n divided by 3 square 1, and so on and so on. That's why that time complexity growth would be log n. So thank you for your watching.